So, the one problem you never really want to see is a problem where I say, you know V naught, you know delta x, and you know delta y, right? But you don't know theta. And then you have to try and find it, right? So then you do this. You do V naught x equals V naught cosine theta equals delta x over delta t, right? And then you do your second equation, delta y equals V naught sine theta delta t minus half g delta t squared, right? And then you can use this to solve for delta t. Delta t is actually delta x over V naught cosine theta, right? So then delta y then is just V naught sine theta over, times delta x over V naught cosine theta, right? Minus g over 2 times delta x over V naught cosine theta squared, okay? Now, from here, you can simplify things a little, right? And then you have delta y equals sine theta times delta x over cosine theta minus g over 2 delta x V naught cosine theta squared, right? And you might recognize that this is basically just tangent. So then we have delta y equals delta x tangent theta minus g over 2 delta x V naught cosine theta squared. Okay? And maybe you might recognize that secant squared theta is equal to 1 over cosine squared theta, right? So then, if we mess around with the numbers a little bit, first off, we recognize that g over 2 times delta x squared over V naught squared times 1 over cosine squared theta, okay? Right? So then you have delta y equals delta x tangent theta minus g over 2 delta x squared over V naught squared secant squared theta. Okay? And then maybe you have delta y, delta x tangent theta minus g over 2 delta x squared over V naught squared tangent squared theta plus 1. Okay? And you rearrange that a little bit, and then you get g over 2 delta x over V naught squared tangent squared theta minus delta x tangent theta. Let me pull that back a little bit. Plus g delta x squared over 2V naught squared minus delta y equals 0. And let's say we put in the constants, right? So then V naught equals, what is that? 10 meters per second. Delta X equals 11 meters. And then delta Y equals 5 meters, right? So then we end up with 9.8 over 2 times 11 over 10 squared tangent squared theta minus, what is that? 11 tangent theta plus 9.8 over 2 times 11 over 10 squared, just a little more, minus 5 equals 0, right? So then you have, then you would want to treat this as maybe x squared, and this is x, right? So then what does that look like? That looks like A, this looks like B, and then this looks like C, right? So you have a quadratic equation, okay? So then that means if you put this whole thing into Wolfram alpha, treating this as tangent, this is x squared and this is just x, you would end up with tangent theta is approximately 0.0886947, right? And tangent theta is approximately 1.76659. So inverse tangent of 1.76659 is approximately 60.49 degrees. Okay? An inverse tangent of 0.0886947 is approximately 5.069 degrees. And you can see why I say that is the problem you never want to see.